Welcome to Lab 3 on the Diverging Lens. At first we'll do a similar observation, looking through the lens and watching as we move it back and forth in front of some text, whether this is with or against motion of the text through the lens.
Light source at the middle of the bench, negative lens in the holder.
We'll start out with the light source far away, move it closer. You can observe the image being formed through the lens. Again, that's a virtual image. This is basically all the way up against the lens. You can see they're both similar in size. And now we're moving farther away. Again, the virtual image appearing through the lens. With the light source all the way at the other end of the bench, the virtual image is quite small. And I'll pan around to sort of see how it moves. To collect the data for this section of the lab, we'll observe parallax. Parallax can be seen here with these two rods. Where I move left and right, you can observe relative motion from one to the other. The close one appears to move back and forth in front of the far one. As they get closer together, that motion is less pronounced. The motion doesn't seem to be as extreme. So we'll use this trick to identify where something is.
Starting here, the top of the rod right there is on the right side of the image I see through the lens. When I move here, the top of the real rod is on the left side of the image. So that can't be located at the position of the image. So we'll have to adjust it. The rod is moving left as if it's in front of the image there. So I'm going to scoot it back and see if I can center it on the arrow in the image. So that's a little tricky. So we're looking at the real rod on top and the image of the light source through the lens. So I've centered the arrow on the middle of the rod. I'm going to check the other side and see if that's still the case. Looks pretty good. See if I can bring it up a little bit. I'm going to check as I move back and forth. That image of the light source through the lens appears to move with and line up with the real physical metal rod. So I'm going to call that good. I'm going to say that's well aligned.
You'll use this technique to measure the image distances for the rest of the lab. Part 4 is a calculation step that you can do on your own. Part 5 is using autocollimation again, this time to measure the power of this unknown lens. Again, we have the screen attached in front of the light source, and we'll use a mirror to reflect light back through that lens and look for it on the screen. You can see a blurry version of that arrow, so I'll need to move the lens closer in order to see clear focused arrow, and that's looking better. Continue to fine-tune that. And then we can ultimately measure the distance when we see a clear image.
And here we have the clear arrow for that autocollimation process. That's with the positive lens, so I can measure that distance. That looks like just at 10 centimeters, which would make that a plus 10D lens.
We can repeat autocollimation with the combination of both plus and minus lenses, and then measure the focal length of that combination, which is 20 centimeters.
Looks like just